In today's lesson, I'm going to do a brief summary of the topics in 5.3, learning about the sum and difference identity for cosine. If you recall, we learned the cofunction identities earlier in the year, and what we learned is that for the different functions that are cofunctions, sine with cosine, secant with cosecant, and tangent with cotangent, that if the cofunctions are equal, then their angles are complementary. So this means that they add to 90 or pi halves. And we're going to use this idea to help us solve for different angles. There are two different ways that you can work through these problems. The way that I showed in red uses the method of saying that 90 minus the given angle is going to equal your answer. If you're working with radians, you can say that pi halves minus the given angle equals your answer. Now, some people prefer to solve an addition problem versus a subtraction problem. So if that's the case, then you could say, for example, if you look at number 3, that pi thirds plus the angle in question are complementary, so they add to pi halves. And by subtracting, I would also find that theta equals pi 6. So it's all a matter of perspective as to whether you'd rather do a subtraction problem or an addition problem. All right, so what we learned today was a new formula for the cosine of a minus b and the cosine of a plus b. And one of the things that we talked about before we actually did the formula was whether or not if I gave you cosine of pi halves minus 0, if that's the same as saying cosine of pi halves minus cosine of 0. What we were trying to determine is whether or not you can or cannot distribute the cosine function. And what we discovered is if we find the left side by doing order of operations, we have cosine of pi halves, which we know to be equal to 0, and we do the right side, cosine of pi halves is 0, cosine of 0 is 1, we get negative 1 on the right side. These are clearly not equal. And what we learned from this is that you cannot distribute the cosine to the angles inside the function. So we are not allowed to distribute the cosine to the angles inside the function. This is a false statement. Instead, what we want to do is you want to use these formulas here for the cosine angle sum or difference. And while this formula looks kind of messy, what I want you to recognize is that the right side of the formulas are both the same, cosine, cosine, sine, sine. The only difference is which sign, like as in positive or negative, is in between the two terms. When I'm working with a subtraction of angles, I add those terms. When I'm working with an addition of angles, I subtract those. That's really the only difference. What we're going to do today is go ahead and finish working through some applications of these problems, and then the next day we'll talk about some more complicated examples. Okay, what you can see here is we're trying to find ways to get the exact value for the angle. And cosine of 15 is not an angle that we know. However, if we can find two angles that we do know and either add or subtract them, then we can come up with cosine of 15. So in this problem, what we do is we say that 45 minus 30 is equal to 15. Therefore, I can go ahead and say cosine of 45 minus 30, and then I can expand that out using the formula. Cosine, cosine plus sine, sine. And then after that, I just go ahead and plug in my unit circle values. Now when we simplify these problems, we're going to see a lot of root 2's and root 6's divided by 4. The only thing that's really going to change is whether the sign is positive or negative. All right, if we take a look at number 6, in this problem I worked it out using two angles to equal negative 5 pi 12ths. Now one of the things that we talked about in class is that based off of our negative angle identities, cosine of negative 5 pi 12ths is also the same as cosine of positive 5 pi 12ths. And the reason for that is because of our negative angle identity, which says cosine of a negative angle is still equal to cosine of the positive of the same angle. So if you'd rather, you can just work this out with a positive angle. You'll get the same answer no matter what. In number 7, what we see here is this formula is the expanded version of our new formula. So when we're working with these problems, we're either going to see something like 5 or 6 where we have to find a way to expand, or we will see something like number 7 where it's already multiplied out and we have to find a way to condense. So what we would want you to notice here is that this is a subtraction of two terms. Therefore, I'm going to see a sum of those two angles. And when I add those angles, I get 180. And whenever I have an angle on within my function that's on my unit circle, I want to go ahead and finish that problem off, and cosine of 180 equals -1. All right, now in this next problem, I give you sine of 15. And a lot of students think that the formula works the same way, except maybe they switch the order of the functions for sine, and that is not true. We currently do not know the formula for a sine angle sum or sine angle difference. Instead, what you want to do is use our idea of cofunctions and rewrite sine of 15 as cosine of 75. And then we can go ahead and expand our formula and go ahead and go through all of the steps like we did in the earlier problem. And I am noticing a typo or a handwriting error right here. This should be root 3 over 2, and this should be 1/2. So that changes my answer to be root 6 minus root 2 over 4. Okay, last example, we are given cosine of 180 plus theta and asked to write in terms of a function of theta. Well, when you look at this, hopefully your first thought is not to do cosine of 180 plus cosine of theta. Hopefully, if nothing else, you'll learn that we cannot distribute the cosine. Instead, we're going to go ahead and expand it. So we expand it with our formula, and after doing so, we can see that cosine of 180 and sine of 180, when their values are plugged in, that second term goes to 0. Therefore, my overall answer is just negative cosine of theta.